Hi student, this video is about non-homogeneous differential equation. The non-homogeneous differential equation is in form of a d square y over dx square plus b dy over dx plus cy equal to fx, where a does not equal to 0 and fx does not equal to 0. The general solution for non-homogeneous differential equation is yx equal to ycx plus ypx, where ycx equal to complementary solution and ypx equal to particular integral. Okay, for this video, I will show you how to solve a non-homogeneous differential equation when fx is a polynomial function. And for this polynomial function, we only cover for quadratic and linear. So you need to remember the standard form for quadratic is ax squared plus bx plus c, and for linear, ax plus b. Okay, next we move to first example. We want to find the solution for d square y over dx square minus 2 dy over dx plus y equal to 2x square minus 5. We can see that on right hand side fx equal to quadratics. This one is quadratic. Okay, the first step to solve a non-homogeneous differential equation, the first step is we want to solve for homogeneous differential equation. So when we want to solve for homogeneous, we need to set the right hand side is equal to 0. And then we can let d square y over dx square equal to m square minus 2m plus, when we want to solve for homogeneous, y actually equal to m power of 0 or equal to 1. So plus 1 equal to 0. So first step, we want to solve for homogeneous differential equation to find yc. Okay, if we factorize, we get m minus 1 times m minus 1 equal to 0. So we get m1 equal to 1, then m2 equal to 1. Means m1 equal to m2. So therefore, the general solution for homogeneous is actually referred to yp. So here ycx equal to a plus bx times e power of mx. So equal to a plus bx times e power of x. So we get yc equal to a plus bx times e power of x. So to solve a non-homogeneous differential equation, first step we need to solve for homogeneous. How to solve for homogeneous? You just set right hand side equal to 0, and we need to find the complementary solution or auxiliary equation or auxiliary solution. You just let d square y over dx square equal to m square, dy over dx equal to m, and y equal to m power of 0 or equal to 1. And then we find the root. Okay, for this equation, we get m1 equal to m2. So the general solution for homogeneous when m1 equal to m2 is a plus bx times e power of mx. So we get yc equal to a plus bx times e power of x. Okay, next step, how to find yp. So yp actually based on fx. Here we have fx equal to 2x square minus 5. So we know that this is quadratic. So ypx, since fx equal to quadratic, you need to write the standard form of quadratics. Since we already use a and b, so you can start with c. So the standard form for quadratic, cx squared plus dx plus e. Okay, yc must not equal to yp. So we need to check this yc. If you expand, you get a e power of x plus bx e power of x. And then you need to compare these two terms with yp. If we have the same term, you need to time yp with x. But if we compare here, we don't have the same term of yc and yp. So we can proceed yp equal to cx squared plus dx plus e, and then y prime p, yp prime x, just differentiate yp, so we get 2cx plus d. Okay, next we find y double prime equal to 2c. So based on our equation or our question, we have a d square y over dx square minus 2 dy over dx plus y equal to 2x square minus 5. So what you need to do, just substitute these three into the original question. So we get d square y over dx square actually refer to y double prime p. So we can substitute with 2c minus 2, and then dy over dx equal to y prime p. So we get 2cx plus d plus, and then y refer to yp, cx square plus dx plus e equal to right hand side 2x square minus 5. And then you need to expand and grouping. So we get 2c equal to 4cx minus 2d plus cx square plus dx plus e equal to 2x square minus 5. Okay, next, if you group this equation, we get cx square plus d minus 4c x plus 2c minus 2d plus e equal to 2x square minus 5. And then we can compare coefficient. So coefficient of x square equal to c. So we get c equal to right hand side, c equal to 2. And then we have coefficient of x, d minus 4c equal to 0. And 2c minus 2d plus e equal to negative 5. So if you solve, you need to solve this. If you solve, you get we get C equal to 2, and then we get D equal to X, and E equal to 7. Get E equal to 7. So based on YPX, based on this YP, we define YP equal to CX square plus DX plus E. So here, YPX equal to CX square plus DX plus E, and then you can substitute C equal to 2x square plus XX plus 7. So the general solution YX equal to YCX plus YPX. So YCX, we get the general solution for homogeneous. We get A plus BX e power of X, and then plus YP 2x square plus XX plus 7. Okay, next, second example. We have d square y over dx square minus 3 dy over dx equal to 3x plus 2. So on right hand side we have linear, fx equal to linear. So first step, this is homogeneous, a non-homogeneous differential equation. Why non-homogeneous? Because on right hand side does not equal to 0. So to solve non-homogeneous, first step you need to solve for homogeneous. How to solve for homogeneous? Just set right hand side equal to 0, and then we can let d square y over dx square equal to m square minus 3 dy over dx equal to m. And the third term, we don't have the third term, so equal to 0, and then factorize on left hand side, we get m times m minus 3 equal to 0. So for the first m equal to 0, second m equal to 3, means m1 does not equal to m2. So the general solution for homogeneous, or we call here as YCX equal to A e power of m1x plus B e power of m2x, and then substitute A e power of 0x plus B e power of 3x. So for the first term, e power of 0x, 0 times x equal to 0, e power of 0 equal to 1. So we get A plus B e power of 3x. So YC here is referred to general solution for homogeneous differential equation. So next step, how to define YP. Okay, YP actually based on fx. So here we have fx equal to 3x plus 2. We have fx equal to 3x plus 2 means linear. So yp equal to the standard form of linear equation is, okay, since we already use a and b, we start with c. Cx plus d. Okay, when we define yp, you need to compare with yc. So, if we have the similar term or same term, you need to time yp with x. If we compare, okay, yc, we have a plus b e power of 3x, and then yp equal to cx plus d. Here we have the same term. The same term here is a equal to d. So a can be 1 and d also can be 1. So since we have the similar term here, what you can do, you need to time this yp with x. So we get new yp equal to cx squared plus dx. And then you need to compare again with yc. So here we don't have term time with x. So we can use yp equal to cx squared plus dx. Okay, next, y prime p x equal to, this is ypx. Okay, y prime just differentiate. So we get 2cx plus d, and then y double prime px equal to 2c. So after we get y prime and y double prime, we just need to substitute into the original equation. So the original equation, we have d square y over dx square minus 3 dy over dx equal to 3x plus 2. And then d square y over dx square, we just need to substitute with y double prime p. So 2c minus 3 dy over dx, we substitute with y prime. So we have 2cx plus d equal to, so we don't have y here, so you don't need to substitute yp. So equal to right hand side 3x plus 2. So we get 2c minus 6cx minus 3d equal to 3x plus 2. So we have negative 6cx plus 2c minus 3d equal to 3x plus 2. So if we compare the coefficient, so negative 6c equal to 3. First equation, second equation, 2c minus 3d equal to 2. So if you solve this, you get c equal to negative 1 over 2 and d equal to negative 1. So ypx equal to, okay, based on what we defined earlier, we have ypx equal to cx squared plus dx. And then substitute c equal to negative 1 over 2x squared minus x. Okay, and sorry for this question, actually we have initial value problem. I want to solve this question when we have initial value problem. X equal to 0, y equal to -1. Number 2, x equal to 0, y prime equal to 5. So when to solve for initial value problem, so we have when y0 equal to -1 mean when x equal to 0, y equal to -1. Number 2, y prime 0 equal to 5 mean when x equal to 0, y prime equal to 5. So what you need to do, for the first value, just need to substitute into yp. For the second value, you need to substitute when you differentiate yp. So differentiate yp, we get y prime px equal to 2cx plus, we don't need to differentiate the general form, just differentiate. -1/2 x squared, so you get -x actually we need to find yx equal to ycx plus ypx. So ycx, we get a plus b e power of 3x, and then plus yp equal to negative. So -1/2 x squared minus x. So this is the general solution for non-homogeneous. But when we have initial value problem, we need to substitute into this yx. So based on the second value, we have x equal to 0, y prime equal to 5. So we need to differentiate this we need to differentiate this yx. So we get y prime x equal to, a refer to constant, differentiate a equal to 0, differentiate second term, we get 3b e power of 3x, differentiate third term, we get minus x and then minus 1. For the first value, we just need to substitute into this one. So if we substitute x equal to 0 and then y equal to -1, so we get -1 equal to, substitute into this, so we get a plus b e power of 3 times 0, so we get b minus this equal to 0 and 0 because we substitute x equal to 0. And then for this second value, just substitute into y prime, so we get -5. So we get 5 equal to, if you substitute x equal to 0, you get 3b, and then x equal to 0 minus 1. If you solve this, we get a equal to -3 and b equal to 2. So we get yx equal to Okay, based on we have yx equal to a plus b e power of 3x minus 1 over 2 x square minus x, and then we can substitute a equal to negative 3, and then b equal to 2 plus 2e power of 3x minus 1 over 2 x square minus x. So here, when we have initial value problem, we know that we can find the value for homogeneous differential equation. Or we can find the value for general solution for homogeneous. Okay, thank you.